What is a motor and what does it do? A motor is a machine, especially one powered by electricity or internal combustion, that supplies motive power for a vehicle or for some other device with moving parts. We use motors every day. For example, cars, refrigerators, computers, and washers. Here are some of the supplies that we used. The battery is used for the source where the electricity comes from. The paper clips, which are attached to the ends of the battery, are used as conductors, and we also need it to hold the coil up. The rubber band was mainly used to make sure that the conductors were attached to the battery. Another piece of equipment we used was the coil, which was modified in order to spin. For the coil, we kept it in the original form but sanded one end completely, and for the other end, we only sanded it on one side. We sanded these wires to get rid of the insulator. Since we needed a magnetic field in order to create the spinning, we added a magnet which stuck to the battery. The motor works because we have a magnetic field. There are two poles, north and south. Based on the right-hand rule, we know which direction the current is flowing. From the motion of the coil, we know that the current is circular-like, and it goes through one end of the wire to the other end. Another important reason why this motor works is because of the sanding. I mentioned before that I sanded one complete end. This is because we need a continual flow. Then I only sanded one side of the wire. This is because we need to keep one side an insulator. In this motor, we cannot have a continual magnetic field, so when the insulator hits the paperclip, we can assume that it is turning off the magnetic field. When the sanded part touches the paperclip, we can assume that it's turning on the magnetic field. During the insulated part, it repels and disables the current, but then it turns to the sanded part, which allows the coil to spin. This is repeated on and off during the spinning process. We can see that when there is no current, the forces are still balanced. There is the force of gravity which pulls down on the coil, and then there is a normal force from the coil to the paperclip because it is touching. So the forces will still be balanced when the current is flowing. There's a force of magnetism which pulls down, and there's also a force of magnetism which pulls up. This is actually what causes the coil to spin. So you can also kind of like see my little drawing that mentions torque. So torque is like kind of a spinning or rotation.